Hello everyone, and welcome to today's web seminar, Maximizing Your Server Memory and Storage Investments with Windows Server 2012 R2. This web seminar is being produced by Windows IT Pro and is sponsored by Kingston Technology. Just a brief note, if you have any technical difficulties during today's web seminar, please press the Help widget on your player console to receive assistance. And if at any time you are having audio difficulties or problems with advancing the slides, simply hit your F5 key to refresh your console. Please also note, today's web seminar will be available to view for 12 months. You will receive an email when ready to review. And now, I would like to introduce our session presenters. John Savill is a Windows Technical Specialist, an 11-time MVP, and an MCSE for Private Cloud and Server Infrastructure 2012. He is also ITIL certified and a CISSP. John is the author of the popular FAQ for Windows and is senior contributing editor to Windows IT Pro. Cameron Crandall currently serves as a Senior Technology Manager with Kingston Technology's SSD Product Engineering Department. In addition to helping lead the engineering efforts for new and current product offerings, Mr. Crandall serves as a technical advisor for Kingston Sales, Marketing, and Public Relations Departments. And with that, John, the floor is yours.
Maximizing your server memory and storage investments with Windows Server 2012 R2. My name is John Savill. I'm a contributing editor for Windows IT Pro magazine and really been working with Windows now for well over 20 years. And really the goal of this portion of the event is to really think about how many companies today are still on legacy versions of Windows Server, and primarily thinking about Windows Server 2003. And then thinking about how far we've come in terms of server hardware, and what does that mean if I'm still running a decade-old operating system? Can I still get the most value out of today's hardware advancements? Can I leverage the huge amounts of memory that I can now install in the server? Can I really efficiently take advantage of things like SSD drives to get the highest performance? So I really want to dive into those sort of aspects during this event. So the agenda is really about thinking, what's the change in hardware landscape when I think about going from Windows 2003 to Windows Server 2012 R2? Really a decade of innovation, of changes in hardware. I want to think about, well, if I do have sort of additional memory, I'm using far more memory intensive applications and environments. What can I do in Windows Server 2012 R2 that, for example, I can't do with my Windows 2003? I want to think about some of the new capabilities though, things like predictive failure analysis or PFA. And there's great capabilities in memory that it can detect errors, it can try and mitigate any negative effects. But there are some even cooler things now available that will detect those problems happening, then actually say, well look, I'm not going to use those pages anymore because that may affect me in a negative way. I want to look at really SSD technology, these solid state drives. Really, what is so great about them, and why do I need a newer operating system to really get the most of it? Why can't I just put an SSD drive in Windows 2003 box? Really, shouldn't I see exactly the same performance? And then taking it really to the highest level, creating an enterprise storage solution with Windows Server 2012 R2, saying I couldn't even consider doing in a Windows 2003 world. And in what role do SSDs play in that, and how do we use them? So let's think about our Windows 2003 world. So are you still using this? And if you look at the numbers, a huge amount of companies are still using it. And the reality is, whether you think it's great or not, you kind of do have to get off of it. Support ends July 14th, 2015. And I think what many organizations forget about is you won't pass an audit. I mean, if you're still running, forget about not being supported by Microsoft, forget about no more patches or anything like that. You simply, if you have to have any kind of audits, any regulatory requirements, you won't pass it with an unsupported operating system. And so we have all these companies running Windows 2003. It's possibly running on the same hardware that it was originally installed on. It's also very common to see it installed on newer hardware. And that newer hardware is really not being leveraged effectively with Windows 2003. Now, when I think about Windows 2003, there was a 64-bit version, but the reality is I doubt anyone listening is running 64-bit Windows 2003. There may be an exception, but by and large, it wasn't really well adopted. If you're running Windows 2003, you're most likely running a 32-bit operating system. And just think about what the requirements were, what the recommendations were in those Windows 2003 days. I needed 128 megabytes minimum RAM, and really 256 megs was the recommendation. The maximum was 4 gigabytes with standard edition. If I went up to the enterprise, I could maybe squeeze in 32 gigabytes. I could support up to 8 processors when I was running the enterprise edition, and it needed about 1.5 gigs of disk space. So when you look at those sort of specifications today, your watch might have higher hardware than that. But this is what Windows 2003 was really architected around. They're the types of hardware that it was built to leverage. So let's think about what we kind of have today. Windows 2012 and Windows 2012 R2 were really built around a very different world. If I think about Windows 2003, virtualization didn't really exist. I didn't think about virtualization with Windows 2003. There were some things kind of in niche ways, but it was mainly deployed on physical hardware. I had lots of client-server applications. When I think about Windows Server 2012 and 2012 R2, it's 70-80% deployed in a virtual environment. It's really designed around these much higher specification environments with higher storage, higher networking, higher compute. If I look at requirements, the minimum today is 512 megs of RAM, and realistically, I don't really think anything would run on that. Really, we think about 2 gigabytes as a real minimum that's useful. And I can go up to 4 terabytes of memory. So massive amounts of memory can be leveraged by the new operating system. It wants 32 gigs of disk space, and it can support up to 64 physical processors, up to 604 logical processors. We live in the world where a physical processor today often has many cores, different compute units. And sometimes those cores support hyperthreading, so I can actually have 2 threads of execution concurrently. So I can get massive amounts of logical processors going in a modern operating system today. And of course, when I think about Windows 2012 or 2012 R2, it's 64-bit only. And this is a huge challenge today. So when companies really think about going from 2003 to 2012 R2, you're making an architecture shift. You're going from 32-bit to 64-bit. I'm likely going from a physical deployment to a virtual deployment. And there are capabilities that exist in Windows 2012 and 2012 R2 that simply weren't there. I have built-in virtualization with Hyper-V. There's remote desktop services that's far richer than the very basic kind of terminal services that was floating around in the early days. I can do application publishing. I can do virtual desktop with their gateway capabilities, driverless printing. When I think about using my disk space, file classification infrastructure, this is a phenomenal feature. It's part of the File Server Resource Manager. File Server Resource Manager gives us real-time file screening, very rich granular quotas, reporting. But file classification infrastructure goes that step further. It actually goes and looks at what's in the message, what's in the document. Based on that, it gives it a classification. Maybe it can mark it as PII, top secret. And then on those classifications, I can then do actions. I can apply a rights management policy to it. I can copy it somewhere. That's just built into Windows Server 2012. Active Directory Federation services for leveraging all these cloud and partners out there. Web application proxy, PowerShell, UEFI, I mean the list just goes on. And that's really a key point. If you're looking right now at a Windows 2003 environment, and you really are saying, okay, I know I need to go to Windows 2012 or 2012 R2 because I have to. Microsoft dropping support, so I have to upgrade. Don't just replace the functionality in 2003 with the same functionality in 2012 and 2012 R2. The chances are there are far richer capabilities, so take some time to look at what I can do now in the base operating system and leverage those capabilities. Maybe I'm using third-party products, maybe I'm having to do very painful manual processes because the OS can't help. That's probably changed today. So take some time, don't just migrate or upgrade and keep things the same way they were. Take time to understand, well, what can it do, and really maximize those investments. But really the goal of this is to focus, well, specifically around what can I do better with memory? What can I do better with the new generation of persistent disk storage, SSDs? So when I think about memory, Windows can now use up to 4 terabytes of memory. But realistically, not many applications can use that. Now there are things like SQL Server. There are these in 2014, these huge memory consuming components. So maybe they could go and use those amounts of memory. But for most other types of application, they will max out way before that actually doing anything efficient with the memory. And so if I have a box with a terabyte of memory, the much better option is to use virtualization. I'm going to carve that physical box up into lots of smaller virtual boxes. I'm going to assign them certain amounts of memory, certain amounts of virtual CPU cores, certain amounts of disk space. So that's what virtualization enables. Now, Hyper-V, which is the in-box virtualization component of Windows, supports up to that 4 terabytes of memory. And the key thing it does is it supports NUMA topology pass-through. And that's really important. If I think about a modern server, I might have 2, 4, 8 processors in there. And for each of those processors, I probably have banks of memory that are really directly connected. And my best possible performance is if I have a process running on a core that's using memory that's directly attached to that processor. That's considered a NUMA node. And that's really what I want to do. Now when I virtualize, ideally, I still want to be able to pass that topology through to my applications. If it's NUMA aware, SQL Server, IIS, they will all take knowledge of that NUMA topology and use it in the right way. Well, I get exactly that. If I go and look, for example, in Hyper-V, and I go to my Hyper-V settings, what I can actually see is, by default, we enable something called NUMA spanning. And what that does is when I'm applying resources to a virtual machine, if it can't source all the memory from a particular NUMA node, it will enable memory to be allocated from other NUMA nodes. It won't if it doesn't have to. It will always try and stay within NUMA nodes. But it will span if it has to. And a lot of times, if you're a very experienced administrator, you're going to turn this off. Because you say, I don't want it to span NUMA nodes. And there's other effects this does, but leave that unless you're very confident of exactly what you want to do. If you understand, well, what turning this off may mean is even though it seems like I've got memory available, some of my VMs may not start. That's because there's not enough memory on its local NUMA node to actually start based on where the cores are. But within actual specific virtual machines, if I go and look at the details of a processor, I see NUMA. It passes that NUMA topology through to the virtual machine. So the virtual machine can make those intelligent decisions about, okay, well, I have these virtual processors. Well, these virtual processors are using these memory areas over here. So my NUMA-aware application running within that VM is going to make the very smartest decisions. And that's a huge thing. Very important that I have that. And I can have up to 1 terabyte of memory and 64 virtual CPUs in a VM. And that's why that NUMA is so important. When I'm talking about 64 virtual CPUs, I'm definitely crossing NUMA nodes. So I need to make sure I pass that information to the VMs. There's dynamic memory. I can intelligently allocate memory as it needs it based on the actual workflow happening within the virtual machine. But outside virtualization, the error correcting technology has been there for a while now. but problems will still happen. And one of the great things really is this predictive failure analysis. And this is something available in Windows Server 2012 and 2012 R2. And essentially what this enables it to do is the Windows hardware error architecture. It can monitor when those ECC memory pages have encountered errors. And if I get a certain number of errors, if I exceed a certain threshold within a certain time interval, then that Windows hardware error architecture will actually take that memory page offline. So what that's going to assure is I'm not going to use that page. So if it really is failing, I'm not running some risk of corruption in my application. I'm going to take that page offline before it actually has any negative impact. And I'm not going to get that with Windows 2003. Windows 2003 does not have those capabilities. I need to really be running a modern operating system to take advantage of these capabilities. What about hard drives? So I would imagine everyone listening to this call, you've got an SSD somewhere. When I think about wanting the highest levels of performance, the lowest power consumption, we think about SSD drives. I know in one of my home servers I built, traditionally I had a bunch of hard disk drives, and I would get okay performance, but then I actually replaced them with a whole stream of SSDs, and it was incredible the difference it makes, just the performance flew. And the reason is, if I think about a traditional hard drive, they really suffer from a performance penalty, because I have these platters, these spinning platters, and I have a head that has to find the information. Well, that head has to move around the disk in a seek action to find, well, where is that piece of data. And if it's doing random access, it's continually having to perform those seeks, it really negatively affects my performance. So an SSD drive has no moving parts. There is no seek. There's no moving ahead to a certain point on a disk to actually find the data. That's why I get these phenomenal speeds with an SSD drive. Whenever I think about random types of I/O, SSDs will really blow away the performance of any kind of spinning platter hard disk drive. Windows Server 2008 R2, Windows 7 and above natively support SSD drives. And that's really important, because if I think about an SSD drive, it's amazing technology. I'm kind of cramming these atoms into these kind of cells, but I need to do things differently. There's a limit to how many times I can keep wiping and writing data. So I want to be efficient. For example, I don't want to defrag an SSD drive. It's pointless anyway. Defragmentation is designed to move all the blocks of a file into a contiguous stream. That makes it far more efficient for a hard disk drive to read that data, because it doesn't have to do lots of seek operations. Well, an SSD doesn't do seek operations, so fragmentation doesn't really affect my performance, so I don't want to do that. But also, if I was doing that defragmentation and I'm moving blocks around all the time, that has an adverse effect on the lifetime of that SSD. So Windows 2008 R2 and above will automatically disable defragmentation. They're not going to run it on it. And I can kind of see that. If I actually go and look, for example, so I've got an SSD drive here. I look at the properties of this thing. Notice Ready Boost is turned off. Doesn't need it. I'm going to talk about that more in a second. When I think about defrag, let's bring that over. Never run. It's not going to run a defrag on an SSD drive because it's smart enough to realize, well, I don't need to do that. It's efficiently optimizing the operating system. So it's not going to defrag. Superfetch is turned off, because what superfetch does is it effectively does defrag. It performs a defragmentation around the components used for the boot sequence that's really predominantly used by prefetch. So that is turned off. Ready Boost is disabled. Ready Boost is really again designed to bring things in and speed up the system. Well, I don't need to do that. If I'm running SSDs, the performance is so high anyway, I don't need to do that. In Windows Server 2012, partitions are automatically aligned to optimize those SSDs during the creation. So it's automatically going to leverage the right sort of layout on the disk to give me the best performance. A nice enhancement of Windows 2012 was around BitLocker. So BitLocker is that volume level encryption. It traditionally would take every single block on the disk and encrypt it. Well, that sounds nice until you realize, well, in an SSD world, that means I'm basically writing to every block. Every single block on the disk I'm going to write to, which is kind of hideous. I don't want to do that. So in Windows 2012, there's actually an option when I protect with BitLocker to say, look, only encrypt where there's data actually written. That's just going to happen for me. All of these optimizations, it detects an SSD, turns off defrag, turns off superfetch, turns off ready boost, aligns the partitions correctly. If I do encrypt with BitLocker, I can say, we'll only encrypt the bits that are written to. I don't know if this is a digression, but this question does come up a lot. Well, it's like, well, okay, if I have an SSD, should I put my page file on it? And to this, I would just say yes, yes, yes. Because hopefully your page file is not used very much. Hopefully you've put enough memory in the box and it's been well architected. I'm not paging. But if I am going to page, if it was used, if you look at how page files actually work, they have a 40:1 ratio of reads to writes. i.e., SSDs can be phenomenal for that. There's lots of very, very small reads. Around 70% are less than 4 kilobytes. Again, that type of hopping around random access is perfect for an SSD. So if I think about if I have the SSD drive and I'm thinking about, well, should I put my page file on it? My guidance is always yes. I think that's going to be huge for you. Now, why is trim important? This is something I'm only going to get in sort of Windows 2008 R2 and above. And it's really important because the way SSDs work is I write to pages, well, I actually write to cells. The cells are organized into pages, and that's the smallest sort of read-writable unit. And then I have pages that are put into blocks. And the reason this is important is I can only erase at a block level. I can't erase individual pages, whereas I'm reading and writing to those pages. And what happens is, because it takes me time, imagine if I didn't have trim. What would happen is I have 2 pages of data to write. And I'm ready to be overwriting these 2 blocks. To enable me to overwrite, I have to basically wipe away the current content. It has to copy all the other data to a memory cache. It then has to do an erase operation on the entire block. It puts the new pages in that memory cache area and then writes back to that entire block. So you can see, even though I'm only writing a small amount of data, it has to copy all the data into a memory cache, then erase the entire block, and then it can put the data back in. So that's going to affect my performance. Now, there's lots of very, very clever algorithms. It tries to not have to do this, it moves things around. But eventually, the disk will fill up. Eventually, this will happen. So what trim does, trim says, well, look, when I perform a delete, normally, the file system, the actual disk doesn't know. NTFS doesn't actually remove the data. It just marks it internally and says, well, I can write over this now. But for an SSD, it's beneficial for it to know when that delete happens. Because now, it can actually go and do stuff in advance. And that's exactly what trim does. With trim, the OS tells the disk, hey, I'm trimming away these blocks. And what happens now in the background is the SSD, in its own time, can copy the data. It can remove those blocks, erase the block, and then move the data back. But now those pages are empty. Because remember, I can write to pages, I just can't overwrite. I can't erase things. So now I have these empty pages. So in the future, if I needed to write, I don't have to go through that whole erase operation. It's going to be far more efficient. And that's what I get with 2008 R2. I get that ability to do that trim. So I'm going to maximize and keep the performance of my SSD drives. Something that if I just stuck an SSD drive in a Windows 2003 box, I'm actually going to lose performance over time. Without this trim, eventually, my writes are actually going to start degrading in performance. So that's why it's really so important to be using a kind of a modern operating system. And again, there's my sad 2003. My 2003 box does not have that capability. But you know, there's something even better. So Windows 2012 introduced storage spaces. And I'm not going to dive into the details, but essentially it enables me to take disks, put them in a pool, and then create, the term is unfortunate. It's called a virtual disk. It's not a VHD. It's just a disk that's virtual in terms of the storage subsystem. It's exposed to Windows like a disk. And I can do parity, I can do mirroring, I can do thin provisioning, fantastic things. All these great capabilities. But here's what's really nice in 2012 R2. It now has native support for SSD. So what I can actually do is I can add to my system a number of SSD drives. And when I create my disks, I can actually say, well, a certain portion of it I want to be SSD. So basically I've now got this tiering capability in the native Windows storage. And what that enables it to do is over time, data is written and read and written and read, and it starts to detect what are the hot blocks, which ones are used the most. It will actually move the hot one into the SSD tier. So I'm now having that native high performance that I would get in a SAN. I have tiering in SAN. That's now part of Windows. If I have native disks, they could be in the box, direct attached, hard disk drives and SSDs. I can do this tiering functionality. Windows will detect what are the hot blocks and move them around, give me the best performance. If I have an external storage enclosure, I can actually put these in an external storage enclosure and I can create a clustered storage space. So I kind of have that exactly here. I have a mix of disks in an external storage enclosure. Some of them are SSDs, some of them are hard disk drives. And then that external storage enclosure is visible to the cluster as clustered storage. You can see I created a virtual disk called storage space VMs, that's the folder it's viewed as. And I see that actually as over here a cluster shared volumes in my cluster. So that native capability using my SSDs and putting them in an external enclosure, I now make them available actually as a clustered storage system. It does something else as well. It actually creates a write-back cache using the SSD drives. So when writes first come into my storage space, it actually writes them to the SSD first, and then it lazily writes them back to the hard disk drives as it needs to. But what this means is even if this thing is super busy, it's not going to have any real effect on my write performance. And this is why it's so important. I mean, this is a new thing in 2012 R2, the ability to use the SSDs as a tier in my storage spaces. I mean, it just really is going to take advantage of that. So, I mean, what's going to benefit? I mean, you think SSDs. I mean, anything that wants high I/O is going to benefit. Some applications have specific functionality to optimize very fast disks, like SSDs. So, SQL Server. SQL Server, I'd want to put my tempDB on an SSD. SQL Server 2012 actually enabled clusters to place their tempDB on local non-clustered shared disks, simply to try and get this aspect of using SSDs for that. SQL Server 2014 introduced buffer pool extension, a way to extend that buffer pool onto super fast drives, and again, they mean SSDs by that. So as I close up, just before I can sort of hand it off so you can hear from our sponsor Kingston, yes, if I give any OS environment faster disks, it's likely going to improve my performance. I mean, that's kind of a no-brainer. But to maintain that performance, to really get the most, I need to optimize the actions when those SSDs are present. That's going to give me that better performance. It's going to prolong the life and performance of the SSD. And when I think about my operating systems, I think about Windows Server 2008 R2 and above are optimized around SSDs. But when I look at Windows Server 2012 R2, Its primary storage enhancement was to better leverage SSDs. It was all built around using SSDs as part of that tiered storage solution to give me that SSD tier for the most popularly used blocks for that write-back cache. And so with that, I guess if it was a closing thought, in addition to make sure obviously you plan your upgrades carefully, make sure you understand what you have, take time to learn what I can do in the newer operating system. Don't just take what you do on 2003 and move it to 2012 R2. You're going to miss out a lot. But go get Windows Server 2012 R2 and put a bunch of SSDs in it. And with that, I'm going to hand it over to our sponsor, Kingston.
Thanks, John. So again, folks, this is Cameron Crandall from Kingston Technology. I work on the SSD engineering team here. And as John mentioned in his presentation here, and this was a learning experience for me as well, is that Server 2012 extends the memory capability as well as gives us an OS that is very much SSD aware, and what that's going to equate to is better performance for the end customer. And this is really exciting to a memory and SSD manufacturer, of course. But this is kind of the technology that we've been waiting for quite some time. You know, we've been enjoying the performance benefits of SSDs now for several years. But there has been some missing components, and the host operating systems being aware of SSDs and being able to make changes and enhancements to increase performance and extend the life of the SSD only makes the solution better. So we're really excited about Server 2012 and what it's going to enable in terms of SSD performance, reliability, as well as memory scalability. So in terms of memory and planning the right memory configuration for your environment, we really look at three areas. Are you maximizing for performance, for capacity, or for low power consumption? And because we can scale memory to great levels now, we have to be aware of a few things. And that's if you're maximizing for performance, we have to take into consideration memory ranking. So we want a balanced configuration, and depending on the platform, you may have to configure your memory modules in a way to get the highest bandwidth out of your memory subsystem. So there are some pretty strict rules in place today in regards to how memory is configured to maximize the bandwidth of the memory performance. If you're maximizing for capacity, we always recommend to buy the highest capacity modules that you can afford. This will enable you more headroom in the future as you begin to grow and expand the capabilities of the server. And then in terms of power consumption, we have standard voltage DIMMs in the marketplace today, as well as low voltage. So if your strategy is a low power consumption server, the DIMMs do exist to run at lower voltage to maximize power use. Moving to SSDs, I think with SSDs in the data center, what we found is that it really comes down to your particular workload. You know, in the client scenario, you know, we very much understand the client operating system and the day-to-day workload of a client system. Basically, what you and I do on our computers every day, we know very well. In a server environment, it's all over the map, right? We have many different types of workloads, whether it be high read, high write, where your bottlenecks exist, and so forth. So with choosing the right SSD for a server workload, it always boils down to the workload and what your daily read and write requirements are. And we always try, and at Kingston here, we always try and tailor the right SSD for the workload. So as John mentioned, Server 2012 is going to offer capabilities for kind of a tiering level of SSD use, and whether you're putting your databases directly on the SSDs, or you're trying to speed up TempDB or your log files. SSDs are an ideal way of doing that. We still don't see refrigerator-sized enclosures full of hard drives being displaced with SSDs today. What we do see is SSDs being purchased and integrated for performance rather than capacity in most cases. So it is a caching tier, whether it's directly attached inside the server or you're in external storage arrays. The SSDs are typically a high-speed storage layer for your I/O needs. So what is the endurance requirement? I guess the first thing you need to look at, are you in an environment where you have more reads than writes, or maybe you're doing more writing than reading? And really if you look at the SSDs that are in the marketplace today by reputable companies, you really have a lot of different choices in terms of what you integrate into your server. We see a lot of our customers integrating our high-end client-level SSDs into their servers because they like the price point. Maybe they're doing more reading than writing, and that endurance level that they're getting out of a high-quality client-level drive is acceptable for the workload they're doing. And then you have SSDs in the marketplace that are designed with a higher PE cycle NAND flash built into them, that you can write to these devices 10 times more than you can to a client level drive. Obviously those come at a higher price point because the cost of the higher endurance flash is obviously more than the client level flash. But in essence, there's again a lot of different SSDs to choose from out there, and it really boils down to the workload. There are several tools available to you, not only from Kingston but from other SSD manufacturers that enable you to look at your workload a little bit closer. You can drop a set of SSDs into an environment and run them for a period of time, and then through smart tools we can extract the data and see what was actually sent from the host and then actually written to the flash. John touched a little bit on this in his presentation about the effects of trim and erasing blocks on an SSD. Each SSD manufacturer kind of has its own secret sauce for extending the life of the SSD. And through these smart tools, we can put a set of SSDs into an environment and extract that data and do some pretty simple math to determine how long that SSD is gonna last in that particular environment under that workload. So again, if you're unsure about your workload, you're not really sure which SSDs to choose for your environment, the tools are available to make the right choice. In the server space, we see we sometimes see a need for power loss protection on an SSD. You'll see this feature offered by several manufacturers, but essentially what power loss protection is a discrete set of power caps that are integrated onto the solid-state drive, and in the event of sudden power loss, any writes that are in motion or in our cache buffers on the SSD will be committed to NAND. And then the second aspect to the power loss protection is we shut down the drive properly. So we send the command to the drive to tell it we're going to shut it down, and it does its last second mapping update. So I see about half of our customers opt for the power loss protection, and the other half don't. So it really depends on kind of on the environment. If you're susceptible to power loss, with today's data centers, there's so much redundant power supplies and UPS is built into these data centers that a lot of customers maybe just don't see the need for the power loss protection on the SSD itself. But we've got other customers that have power that is unstable, and they opt for the power loss protection. So it does come at a slight price increase over a drive that doesn't have power loss protection, but it does ensure that if power is lost to the drive during I/O, we're going to commit any writes to the flash and then shut the drive down properly. So several choices out there. We try and make it as easy as possible to understand. We've got quite a bit of information on our website about using SSDs in data center servers, power loss protection, and choosing the right SSD for your application. The best advice I can give you is choose SSDs from reputable companies, and really try and assess your workload and your needs in terms of what is the right SSD for your application. And I think that with that, you'll be able to configure cost-effective, high-speed storage solutions. So with that, I will turn it back over to Jake for questions.
Fantastic. Thanks a lot, Cameron. And before we do begin the Q&A session, I would like to ask the audience to please take our survey by clicking on the red survey widget on your audience console. A few of you have submitted questions. We have some time for Q&A, so if you do have questions for either John or Cameron, please put those into the queue. And here's our first question. Could we have an SSD drive as a bootable drive?
Yeah, so this is John. So I think definitely the answer is yes to that. I mean, if you look at a lot of the modern kind of slate devices, desktops, I mean, you get that great performance. You get very, very fast startup times. And if you look at our modern systems today, they generally do have SSDs as the boot drive. So certainly there's nothing to stop you doing it. And to really get those fastest startup times and just overall performance, I think, yes, it's a great thing to do.
Thanks, John. And Cameron, did you have something to add on that?
Sorry, yeah, John pretty much said it there. But yeah, I think that it is very common to have mirrored boot drives with SSDs. A lot of customers will move to SSDs for boot drives simply from a reliability factor. So they just want to remove the spindle device in place of SSD. So yeah, definitely a very common server configuration for SSDs.
Fantastic. Thank you, gentlemen. Here's our next question. I understand the point about not defragging an SSD. One of my server C drives shows 12% fragmentation. If it ever gets to 50% defragmented, or is there ever a point where one would want to infrequently defrag an SSD?
I'll be interested to see what Cameron says about that.
Okay, so we on an SSD we want the data to be fragmented, right? So wear leveling is a key component to any flash device, whether it's an SSD, a USB drive, a flash card. We're always distributing data across the drive so that we're wearing out our blocks evenly. So it does not help to even defrag an SSD from time to time. We really want that data to be fragmented. I think that what's more critical is the garbage collection routines that we do in the background to clean up invalid data on the drive. So this is basically deleted data. Trim is helping in this scenario as well. But really there is no need to defrag an SSD. We've even done some testing in our labs where we've defragged an SSD, and within a very short period of time, minutes, the SSD controller has defragmented the data again already. So there's really no point in defragging an SSD. We want the data to be fragmented so we can do our wear leveling.
Great. Thanks a lot, Cameron. Here's our next question. Not to confuse the issue, but is Optimize in Server 2012 R2 synonymous with trim for SSDs?
optimized. I'm actually going to have to double check on that. I'd be interested in what context you're seeing that. I think it might be more synonymous with fragmentation. But I think I'd want to see you in the context for that.
All right. Thanks a lot, John. Here's our next question. Does Kingston have a site or web location that teaches memory configuration to maximize performance and capacity?
Yeah, we do. Yeah, so you want to go to our website, select server from our main memory configurator to learn more about memory configuration. So yeah, all of those different memory configurations and balanced memory configuration settings are on our website under our configurator.
Thank you, Cameron.
And
sorry, go ahead.
One more thing there. So, and then we also offer free configuration consultations by using our Ask an Expert tool on our website as well. So you can go onto our website and go to our Ask an Expert, and then we'll respond quickly.
Great. Thanks a lot, Cameron. Here's our next question. What is the expected lifetime for an SSD compared to a physical disk?
So it depends on the workload and how much you're writing to the data, or to the drive. In terms of reliability, I mean, I think there are several studies that have been done over the last couple of years in terms of how much more reliable an SSD is, and you can find that pretty easily. But in terms of endurance and workload, it really how long an SSD is going to last in an environment really depends on the right workload that is basically thrown at it. So how random the data is that's coming into the SSD, how much write activity is taking place, and then the type of SSD you're using. So as I mentioned earlier, we have drives that are built with NAND flash that is rated at 3,000 PE cycles. That's the number of times you can program and erase that cell. And that's what's typically in most of the client-level drives that are in the marketplace today, and Kingston's drives. And then you've got the server class of SSDs that use anywhere from 10,000 to 30,000 program erase cycles for the flash. And with that, you get nearly 10 times the endurance that you would get out of a client-level drive. So it really depends on the workload that the SSD is being used for. Really determines how long it's going to last. So I mean, if you're using a 30,000 PE cycle drive in more of a read type application, you can expect that SSD to last a very, very long time. Probably it'll outlast the useful life of the system. But if you're writing excessively to an SSD or to an SSD array, then the life is going to be shorter. There are several tools built into SSDs today to monitor not only the health but the life expectancy of the SSD. So at Kingston, we have a smart attribute within the SSDs called SSD Life Left. And as a user, you can go in and look at this attribute periodically to see how much life is left on the drive. So it starts out at a value of 100, and it descends to 0 over time. So those tools are available, but it really boils down to the workload that the SSD is being used in.
Fantastic. Thanks a lot, Cameron. With regard to SSD tiering, would you recommend the enterprise drives due to read-write?
I think if you were going to use actually like the storage spaces, and so actually using this in like an enterprise environment for enterprise level sort of workloads, I think yes, you would use the enterprise level SSDs. You wouldn't use the consumer drives.
Great. Thanks a lot, John. Next question. What is the I/O protocol for SSDs? Can SSD fit disk drive protocols?
So an SSD to just an operating system just looks like another disk. It's not really treated. There's different maybe device drivers, but it's not really treated anything special. What does happen, as I kind of talked about from the operating system, is it does detect some of the sort of maybe instructions that are available, and then that can open up things like the trim, which gives us the increased performance. Cameron, if you have other comments.
No, yeah, we're using the SATA and SAS host interfaces, so we're using standard protocols there. So yeah, that's correct.
Fantastic. Thanks, gentlemen. Here's our next question. Does Windows 8 and 8R2 use the same write technology as 2012?
Yes, I mean, Windows 8 is basically the same operating as Windows Server 2012. Windows 8.1 is the same operating system as 2012 R2. There's sort of differences in registry, differences in subsystems, but the core kernel is the same OS. So yes.
Thanks, John. Can you talk a little bit about the benefits achieved from logical NTFS, for example, defragmentation?
Could you repeat the question?
Yeah, can you talk about the benefits that are achieved from logical NTFS, for example, defragmentation?
So generally, the benefit of defragmentation is we have a file and it gets separated over the disk as writes occurs, files expand, and so that data gets spread over the disk. So when we try and read the data on a traditional disk, it kind of has to do a lot of seek operations to sort of find all the different blocks of the disk. So if I'm performing a read, and let's say it's a contiguous read, sequential, then if I've got a fragmented file, then I read a little bit, then I have to do a seek operation, which takes time. Then I have to get the next bit of data, then another seek operation. And that affects my performance. And so what normally happens on a sort of a platter, a hard disk drive, is the fragmentation. When we do a defrag, it brings all the pieces of the file together and kind of makes it contiguous on disk. So then there's not those seek actions between trying to read the data. But kind of obviously, as we've talked about with an SSD, we don't have the seek time. Seek time is kind of 0. So we actually don't care. And as Cameron said, we actually like the fragmentation. But normally in a traditional disk, performing a defrag will bring all the parts of a file together. Sometimes it will even move it to kind of the inside of the disk to speed up that performance.
Great. Thanks a lot, John. Here's our next question. What is the MTTF of an SSD on a server versus personal computer?
Cameron, I think I'll give you the mean time to failure.
Well, I think it's the same. The mean time to failure is tied to the NAND, but there wouldn't be any difference between a client machine and a server class machine. I'm not sure how to answer that. Because the NAND flash wears. It has a finite number of write cycles, is part of the mean time to failure specification. I'm not entirely sure what the question there is, but there would be no difference between server and client other than maybe the workload and exhausting the NAND cell.
I wonder if they're asking between an enterprise SSD and a consumer SSD.
Then that would be closely tied to the NAND flash. So a 30,000 PE cycle a device would have a higher mean time to failure than a client class SSD.
Right.
Thanks, gentlemen. And it looks like we have time for just one more question. And here's that question. I bought a smaller SSD for my swap file and temp files to help preserve my 1 terabyte SSDs. Should I also minimize other write-intensive operations to the smaller SSD?
I mean, again, I think obviously Cameron's going to be the expert on sort of the SSD lifetime, but I think anytime you can avoid unnecessary kind of writes is a good thing. But at the same time, I mean, they are designed obviously to be used, and they have a certain resilience and a certain number of cycles. So I don't know if you need to be sort of overly concerned about everything you're doing, but I mean, if there are things you can do to minimize without affecting its usability, then I generally think that's a good thing. Cameron?
Yeah, the higher capacity drives generally have higher endurance. So if you were going to lean one way or the other to put more writes on an SSD, and you had one SSD that was larger than the other, it might be a good idea to put those writes on the larger capacity drive. And the reason is you fundamentally get free NAND space with the larger capacity drives that you're using. So it's about 4% of the total drive capacity. There's hidden spare area for the controller to use for bad block remapping. So that's why you'll generally see on SSD specifications the endurance spec increases as the drive capacity increases. So if you were looking to put more writes onto an SSD, from a wear perspective, you'd be better off putting it on the higher capacity drive. In this particular case, I can see they've got two SSDs on the system to offload writes from the two drives, but kind of depending on where you are in your application and what you've already got being written to the smaller drive, you may opt to send those additional writes to the larger capacity drive because that's where you've got more endurance.
Great, thanks, gentlemen. And actually, Cameron, there's one more question for you. Can you talk a little bit about if you have a video or walkthrough for setting up an external SSD array as a clustered share volume in 2012 R2?
We don't have it. We have a general RAID video. We've got several actually on how to set up and configure SSD RAID arrays, but not specific to Server 2012. But I'm being told it's something that we're working on creating through our marketing group here. So it's forthcoming. But we do today have videos on our website that talk about putting SSDs into RAID arrays and what sort of performance you should expect from various RAID levels.
So this is John. I've actually, on my sort of YouTube, I've actually got a walkthrough of creating a clustered storage space in 2012 R2. So in that I use an external storage enclosure, and I do that tiering. So on my, if you just youtube.com/NTFAQ guy, I have actually got a video on setting that up.
Great. Thanks a lot, gentlemen. And I am afraid we have run out of time for this seminar. I'd like to thank Kingston Technology for sponsoring this session, and of course, John and Cameron for their great presentations. Just a reminder, this web seminar will be available on demand starting tomorrow, so feel free to come back and review. Have a great day, everyone, and thank you so much for attending.